Okay, and last but not least, topic 12, review on probability. We're just going to focus on the first two lessons. So if you look at your paper, I think I gave you, 12.2 through 12.6, but you only need 12 or 12.1 through 12.6, but you need 12.1 and 12.2. So just these first two sections. All right, so this first section. So first of all, probability is on the state test a lot. I don't know why. They must really think that probability is important for you to understand, but this is geometry class, right? But it is what it is. So the first concept we talk about are mutually exclusive events, right? If two events have no outcomes in common, then they're called mutually exclusive. No outcomes in common, okay? If you have mutually exclusive events, to find the probability of A or B happening, you just add up the individual probabilities, right? So in this case, right, we want to find the probability of A, a number less than 3, or B, a number greater than 5, right? So there are two numbers less than 3. There's a 1 and a 2. And there are one number greater than 5, and that'd be a 6. So you have a 2 out of 6 chance of being less than 3, and a 1 out of 6 chance of being greater than 5. So that gives you a probability of 3 out of 6, which is going to be 1/2. And again, if you think about this, the numbers that are less than 3 are 1 and 2, and the number greater than 5 are 6. So that's 3 out of the 6 numbers. Okay. Now, say you want to find the probability that something does not occur. So say you want to find the probability of not having a number less than 3, right? So not a complement, right? Then you're going to take the probability of 1 minus the probability of A. So if I want to find the numbers that are not less than 3, that would mean, so A complement would be all the numbers that are greater than or equal to 3, right? Which would be a 3, a 4, a 5, or a 6. So that'd be 4 out of 6, right? So the probability of A was 2 out of 6. So if you do 1 minus 2 out of 6, that will give you 4 out of 6, because 1 is 6 out of 6. 6 out of 6 minus 2 out of 6 is 4 out of 6. So you can do 1 minus the probability to get the not. That's called the complement, okay? Again, does not occur. The other thing we want to talk about is non-mutually exclusive. This is a big idea. So if they're non-mutually exclusive, non-mutually, that's supposed to say mutually, non-mutually exclusive. So non. So for instance, how about these two events? How about A, a number less than 3, but now how about B, an even number? So the numbers less than 3 are 1 and 2, and then your even numbers are 2, 4, and 6. Okay? So we have a probability of A or B, sorry for the sideways writing, equals, okay, so what's the probability of having a number less than 3? Well, it's 2 out of 6. What's the probability of having an even number? That's these 3 out of 6. But now, the problem here is that you have a number in common, right? This 2 and this 2. They're counted in both of these. So you have to subtract that 2 one time. So I'm not subtracting 2 out of 6. I'm subtracting 1 out of 6 because it's one number. So this is 2 plus 3, which is 5. 5 minus 1 is 4 out of 6, which is 2/3. Again, they'll accept 4 out of 6. But again, the idea here is because they overlap, because they are non-mutual, because they have events in common, you have to use this subtraction idea. This is called the general addition rule. It's on the formula sheet. The general addition rule. Again, my handwriting is terrible. I apologize. I'm going fast, right? Trying to make this as painless as possible for you. But again, if I look at this spinner, right, I want to find the probability of a number less than 3 or an even number. So a number less than 3 would be a 1 and a 2. An even number, we already counted 2, so it'd be a 4 and a 6, right? So it'd be 4 out of 6 numbers. So you want to make sure you don't count numbers twice. Okay? All right, on the other side here, we have independent events. So two events that are independent do not affect the other. This is the major thing here. And you're going to see this on the state test, right? They're going to give you the probability of A and B, and then the probability of either A or the probability of either B. And they'll want the other one, right? So they're going to want you to use this formula here. And they're going to set up an equation and just solve for the unknown probability. Now, sometimes the word and is an upside down U. So they might give you the probability of D and M. Over here, or is sometimes a U, so probability of A or B. So be aware of the U versus the upside down A. Okay. And again, you just multiply the probabilities if they're independent. You're looking for the and. So or addition and multiplication. So that is topic or lesson 12.1. And then 12.2 on conditional probability. So conditional probability involves two events. Typically, it involves what's called a two-way table. So I'm going to make a quick little two-way table over here. We're going to do gender, so boy and girl, and we'll have a total row. And then whether they're in the band or the choir, right? So we'll do band or choir. And again, this is just an example, so I don't really care. It's legitimacy. And there's the total column. So say that there are 4 boys in band, and again, I know this is small numbers, and 6 girls in band. Say there are 7 boys in choir and 3 girls in choir. So that means there's 11 total boys, there's 9 total girls, there's 20 total people, right? And there are 10 total band members and 10 total choir members. So this is our two-way table, right? And again, sometimes you have to fill this in. Well, we can do what are called conditional probabilities. So conditional probability is finding the event of one thing given that the other occurred. So we're trying to find the probability of B given that A already happened, right? So what you do here is you focus your attention not on everybody, right? We're not going to focus our attention on this 20. We're going to focus our attention on just the given event, A. So what if I want to find the probability that somebody is in band given that they're a girl? This is band, sorry. Well, that means I'm going to focus on just the girls on the bottom, and the top are going to be all the bands and girls, right? And. Well, how many girls are there? Well, we look at this row. There are 9 girls. And of those 9 girls, how many are also in the band? Well, 6 of them. That would be your conditional probability. 6 out of 9 or 2/3. So 2/3 of all the girls are in the band. That means that only 1/3 of all the girls, 3 out of 9, are in the choir. And that would give you your total number of girls. That's a conditional probability. Now, we can also test for independence using conditional probability. Events A and B are independent if and only if the conditional probability of A given B is the same as the probability of A. Right down here, A given B equals A. So for instance, this is the probability that someone's in band given they're a girl. Now let me find the probability that someone's just in band. Well, now I look at all the band members, that'd be 10, out of the total, and the grand total is 20. So 10 out of 20 is 1/2. Obviously, right, these two numbers are not the same. They're not equal. So because these two numbers are not equal, that means that these two events are not independent. Right? 2/3 of girls are in band, but only 1/2 of the students are in band. So what this means is that you have a higher percentage, a higher chance of being in band if you're a girl. That is not an independent situation, right? Being a girl means you have more of a chance of being in band than if you're just anybody. But if these two events would have been, if these two probabilities would have been the same, then it doesn't matter if you're a girl or a boy, the probability of being in the band is the same. So this is a lot. This is heavy stuff. I get it, all right? But again, they love probability on the state test, so do your best to understand it. Okay, all right. And that concludes our topic review on geometry.